Hello everyone and welcome. This is our series on science and technology, and in this lecture we'll be continuing with nanotechnology and we'll finish it off. Uh, do you know the meaning of frontier? I hope you do. If you don't, Google it. It'll help you understand why I have chosen this photo. It says a new frontier. All right. Of course, it means basically a new horizon of technology of the way we live. But still, I'd like you to Google that and understand what this term means. All right. You can use this in basically it's a keyword which you can use in your essays and some answers also, but only if it is relevant. Do not write something which is not relevant. That is very important. To begin with, we had left off in the last lecture on applications. So this time we will be seeing some new things that have developed and some very good applications of nanotech. So first one of these application is quantum dots. These are small crystals, basically nanoscale crystals, in which you can transport electrons. And how can we use this? Basically, these things are used as indicators, or they can be used as light emitters. So these are right now being used in TV screens. Many very costly TV screens are using quantum dots for better display. All right. So quantum dots are basically man-made crystals at nanoscale, which can be used to transport electron. So one quality that they have is that they will emit only one light. These quantum dots, one quantum dot will produce only one color. Basically, you can design that. Okay. These will be or these are being used in solar cells also. All right, and they are also described as artificial atoms, so do remember that. This is a good this is not easily found, so these are also called as artificial atoms, right? So how do they work? Basically, when a blue light hits any of the quantum dot, depending on its size it will emit a color. So as you can see, blue light is hitting and the size of this quantum dot is 2 nanometer, it will emit light green. If the size of the quantum dot is 6 nanometer, it will emit red light. All right. So there are various applications like I told you in solar panel, then uh, TV screens and so on. Okay. So this is how they look according to the size, and they will emit a certain color when blue light hits them. Right. This is how they look in the laboratory. Again, whenever you are reading about all of these things, even if you're reading some current affairs on your own, please don't try to go into a lot of depth. Just try to relate things. Just try to understand from the surface level only. UPSC is not going to ask the technical thing, how it works, what nanometer size should be there. No. They will basically ask, is there, or they will ask, artificial atoms are now being developed like this. Okay. So yes, they are being developed. So nanobots. Now again, do not confuse this with something like Iron Man built in the movies. Those are fictional things. They are very far into the future. All right. Right now, basically you need to understand, for medical purposes, or even mostly it is for medical purposes, such robots are tiny robots. Nanobots are very tiny robots. All right, which can be programmed. All right. So nanobots are not something like Iron Man's suit in Avengers Infinity War. They are basically small robots that can be programmed, which will go into your body and then carry out something specific. So this is reality. This happens right now. All right. So why are these important? What are the applications? We always have to see the application of a thing, where it can be applied or where it is applied. Whatever you can see or whatever you can read about, read it. So in application, we need to understand why it is important. See, right now, whenever you take a medicine, it goes to your entire body. Of course, then also it will reach the affected area. But what if we want to increase the efficacy, or we want to increase the reaction time, or basically we want to reduce the time taken to reach the affected site? So nanotechnology comes to the rescue. Here, the drug can be sent directly to the affected location, which will obviously reduce the time taken, and the best benefit would be it will reduce the side effects also, because now when you take a medicine, it goes around the, obviously it enters the blood and it goes around to every organ. So extensive testing also has to be done so as to make sure that any medicine when released to the public does not affect normal organs in a negative way. All right, for example, nanorobots or nanobots can be programmed in order to break a blood supply blockage also. They can just directly go into that, let's say, vein, or blood vessel, and then it can shrink the tumor or shrink the anything that is blocking the blood flow. So this can be done directly. See how small it is. And on the right hand side you can see this is a computer graphics. Here you can see red blood cells and small robots. All right, so some this application actually exists right now. It's not like something in the future. This is actually being done nowadays. Next we come to DNA technology, right, or rather DNA nanotechnology. Now this is a very interesting thing, because DNA as a structure, as an organic structure, as a natural structure, it has a lot of features. Like it self-replicates. That means it can copy itself, and it has large storage area also. So scientists got curious about it. So they started searching more and researching more, and then they realized that we can actually develop our own DNA, and that is what is nanotechnology. DNA nanotechnology is about. So basically, it's a branch of nanotechnology in which you create, study, and apply, or you create applications out of DNA. Now, this does not mean that the DNA is taken from humans. No, it is actually artificially created, right? So, nanostructures are created, like DNA shaped nanostructures are created for application in physics, chemistry, and biology. All right. Now, where would it be applicable? Now, I have written two examples over here. First is in electrical circuits, it will help a lot. If a circuit goes bad, if a chip goes bad, it can cure itself. Now, that would be sort of magical, right? If a chip goes bad, a circuit, basically, let's say due to high voltage, the circuit goes bad, then what? Then, rather than removing the chip, you can actually see, or rather than removing the chip or replacing the chip will repair itself. Now that is possible because, like I said, DNA self-replicates, DNA self-assembles, all right, and it can adapt also various states and conformations. Again, we don't need to go into depth. This is very technical again. If we go beyond this, it will become very academic and technical. We don't need to do that. We just need to see where it can be applied. And for your knowledge, I have given you the reason. Second point is storage. It can be used and it will be used to store a lot of data. It is much more efficient than currently the storage system we use, like the magnetic disks, even pen drive also. Because DNA is very compact, it's very energy efficient, and DNA will survive for hundred of years. Files stored in DNA can also be copied easily for negligible cost. So this research is currently going on this, and yes, it is, forget research, it is already agreed to that DNA will be used for storage in very near future. And that will not be DNA that is from your body or my body or anybody's biological body. It will be created in a lab, but it will be obviously like the natural DNA. Now let's understand carbon nanotubes. We hear about them a lot. So carbon nanotubes are basically cylinders, hollow cylinders that have a single layer of carbon atom, which is basically graphene. So if you see the diagram, let me zoom in. So this is one layer, all right. Then it in the second stage, it starts folding and then it forms a cylinder. So a carbon nanotube is a hollow cylinder of single layer carbon atoms. Remember that, single layer. Now they are very lightweight. The best thing about them is they are very lightweight, almost 1/6 weight of the steel, and their tensile strength is almost 400 times of that steel. So it is an amazing material, right? Sort of a marvel, you can say, a technological marvel. So 1/6 the weight of steel, right? Then 400 times stronger also. So this is the comparison which you can do, and can now imagine that if I think you everybody must be aware, steel is an integral part of our life. Now just imagine if it could be replaced by carbon nanotubes, right? Our utensils, even electrical appliances, and so on. That will become very light and much more powerful. So basically right now it's not that cheap that it can be used in day-to-day life things. Right now it is available for industries only. Okay. Now again, applications, because that should be our main focus. The main applications are basically in medicine. All right. Delivery of medicine to the proper site, then regenerating tissue, right? Then creating sensors that can go into the body and send the accurate data, and so on. One of the features of carbon nanotube is that they have high surface area. That means high surface area means they will react with the host, or they will react with the surface very quickly. All right. Carbon nanotubes are also biodegradable. Very important point. Bacteria, fungus, and other type of microbes can degrade carbon nanotubes. All right. So they have high surface area. They are biodegradable, and mostly right now they are being used in pharmacy and medicines. Mostly it is about getting correct diagnosis, then delivering the drug accurately to the right place. Next, we come to the last application, which is nanomaterials based supercapacitors. Again, this is an issue that is coming up. That is why I have taken this technology. So, see, in the world right now, there is a very high rate of increase in the global energy consumption. And we also know that the environmental impact of traditional ways of producing energy, which is the coal, right, thermal power plant, such things have environmental cost. And we are slowly shifting towards clean and renewable energy, solar, wind, right? So, as these new energies are taking over, we need new systems where we can store large amount of electricity, right? Also, basically, we need, what I mean to say is we need advanced storage system for electricity, because sunlight does not come in the night. Secondly, not always wind will blow. So windmills also need proper storage devices. And then of course electrical vehicles. So such things like supercapacitors are theorized to hold much better charge than the current batteries. So keeping this in mind, the researchers have been working on carbon nanotubes nanomaterial, right? And creating supercapacitors out of it to achieve high energy density and power density, all right, to also to increase sup- uh, power density of supercapacitors. All right. So high energy density means that good amount of current can be continuously withdrawn for a longer duration. This will help in what? This will help in automobiles. Right now, range is very limited, 100 to 200 kilometers. It might be increased to 500 to 1000 kilometers. All right. So researchers have developed a graphene oxide at 100 temperature with high capacitance. All right. It is cost effective and suitable for commercial purposes. But again, the temperature is a bit high, so they are working on it. So basically, supercapacitor has been built with the help of nanotechnology. All right. So basically, we need to focus on cost effective and efficient devices which can be used for energy storage application. So I have given you the example, I've told you why we are doing this. All right. So this is how it will look. Carbon nanotube graphene, it is used to create a flexible supercapacitor. Again, we don't need to understand the technical know-how of it. We just need to understand that it works. There is something like this and it will be used to store energy. Now there are two terms that were used, uh, energy density and power density. So energy density is the amount of energy that can be stored in a given mass of substance. Basically, how much can you store in a battery? That is the energy density. Power density is the amount of power it will give per unit, right? So it is basically a measure of how late or how fast, or let's say how quick or how slow the battery will release the energy. So energy density and power density. Energy density is about storage, power density is about power delivery. So this was about nanomaterials based supercapacitors. No, these are not normal supercapacitors. These are nanomaterial based. All right. All right. So till now we have seen the applications. Now we will quickly see the evolution, current status, then few guidelines and policies that are and schemes that are there for this topic. So let us talk about the evolution briefly. You don't have to remember a lot of things from this. Just understand that India became aware of what things and when. So in ninth 5-year plan, it was mentioned for the first time that some institutions or some facilities would be set up for frontier areas or frontier technologies of science and technology like superconductivity, robotic, neurosciences, carbon and nanomaterials. But a special program was launched in 2000, program on nanomaterials, science and devices, which gave a good shot in the arm to the nanotechnology research in India. Now, in 2001, Nanoscience and Technology Initiative NSTI was launched. The 11th 5-year plan saw the launch of Nano mission, which is quite an important mission. It was given a lot of big objectives and it had a good amount of funding also. Under 12th 5-year plan, the second phase of Nano mission was started, right? That's all you need to know. Now, what is the result of these initiatives? Of course, we have launched few things, but what is to show? Like what have we done? So basically, India has published over 23,000 papers in nanoscience. India ranked third in papers published in 2018 behind only US and China, which is very good. There have been many patent applications filed in this field. All right. Then in terms of researches also, India ranks third after China and USA. According to a report by ASSOCHAM, all right, the global nanotechnology industry would require about 2 million professionals, basically 20 lakh, from 2015 onwards, and India is expected to contribute about 25%. So this is again good for our jobs. All right. Do read about jobless growth. And this reminds me of this. So do read about this phenomena. India has published over this. We have talked about this. All right. Okay. This was repeated. Let's move ahead. So who are the major stakeholders in India which take care of nanotechnology. So Department of Science and Technology, Department of Biotechnology, Department of Electronics and IT, Department of Industrial Policy and Promotion. So all of these are involved in integrating nanotechnology into government policy and implementing the programs. So let us quickly see the policies and guidelines. We need to understand in policy and guidelines, we need to understand why this policy was given, what are the effects of it, what are the applications. We don't need to go into depth of anything. Please remember that always. Try to cover as much as possible and do not go much into depth. For any point that you read, you should have 4 to 5 points. That's it. Keep that as a standard. So first, of course, we will study about the National Mission on Nanotechnology. Its name is Mission on Nanoscience and Technology, nicknamed as Nano Mission. So it was launched in 2007 as an umbrella capacity building program. That means it had a lot of things under it. Umbrella means it had a lot of things under it. It's a major program. Alright. Department of Science and Technology is the nodal agency, but Department of Biotechnology will be promoting or focusing on things in life sciences. DST, Department of Science and Technology, will be overall implementing things. DBT will be focusing on life sciences. What are the features of this mission? Basically, capacity building will be there. Capacity building means teaching people, like training, providing them with proper laboratories, providing them with proper tools to research. Then there will be infrastructure development, international collaborations, then development, like nano applications. Things will actually be developed, some product will be developed, human resource development. So all these things are to be done under this program. So what has been the performance? India is among top 5 nations in terms of nanotechnology and its research. The Nano mission itself has resulted in about 5,000 research papers, 9,000 PhDs, useful products also, like hydrogel based eye drops, pesticide removal technology for drinking water, water filters for arsenic, fluoride removal, nano silver based antimicrobial textile coating, and so on. So this is an important point which you can note down. Also, Indian scientists have received access to the state-of-the-art facility like photon factory at Tsukuba, Japan. This is due to the international collaboration part, which I mentioned in the features of the Nano mission. So basically, Nano mission has helped in development of good ecosystem. That means humans, labs, international collaboration, then research and development of products. So it has been by and large, a successful program. What are the other initiatives? Nanoscience and Technology Initiative. It was launched in 2001. It was, let's say, precursor or the predecessor of Nano mission. So don't need to know about it. It's like 20 years old. Nanotechnology Initiative Program. It comes under Department of Information Technology. It was started in 2004 and it focuses on nano electronics. Focuses on nano electronics. So it will focus on developing again institutional capacity building, infrastructure, same things like Nano mission, human resource development, but in the area of nano electronics. That is the difference. Then the Center of Excellence in Nano Electronics was established at IIT Bombay, ISC Bangalore. But again, no need to focus on that much. But just try to understand whatever these programs are, they will try to develop human resource. They will try to develop infrastructure, international collaboration, basic capacity building. So all these things are very common. Next, we come to guidelines and best practices for safe handling of nanomaterials in research labs and industries. These are the guidelines. Okay, quite important. We'll just know briefly. We don't need to go into depth. So these were launched under the Nano mission. Under the Nano mission, these guidelines were launched. So these guidelines just simply tell the people on how to handle the nanomaterial. That's all. And and it tells the standard operating procedure for handling nanomaterial in laboratories, in industries. All right, it tells you if something goes wrong, then how do you need to control it. All right, it tells that how and where you should wear protective suits or how to use protective equipment, and if something gets leaked, how to react. So all these things are given in the guidelines. All right. Next, guidelines for evaluation of nano based agriculture input and food products in India. We have already discussed about this. All right. One thing which I would like to mention here in this guideline is, at present in the world, there are no unanimously accepted international guidelines for nano agri products. This is very important. Right now, research is going on, people are developing things, but again, things are not at such level where you can actually say that yes, this is a good product, let's not create policy for future. All right. So basically what I'm saying is, this is not a matured industry. It's this industry is in its nascent stage. Lot of things have to be developed yet. So we need to be very careful and create a very good, robust, let's say, the guidelines. All right. There are few provisions, but again, these are just guidelines from WHO. There is no strict rule that needs to be followed by transporting or by creating nano agro products. All right. But whenever we try to create guidelines for a new technology, we will always face an issue that it develops very fast. Always policy follows behind the innovation. All right. So yes, it's quite difficult to do such things, but we can change. I mean to say, we can create some things that research can happen after the guidelines come. All right. What I mean to say is, if technologically smart people are there in the policy making, they might be able to create enabling policies rather than red tapeism policies. All right. Again, this is a good point, that in case by case basis you can evaluate and then approve or disprove some technology. What are the various international collaborations that have been done? We can this is just factual stuff, no need to understand anything. So initiatives for joint research and development have been done with the US, EU, Japan, Taiwan and Russia, of course with India. The Science and Technological Department of Brazil, South Africa, and India have started a trilateral initiative. All right, and nanotechnology is one of the field which will be researched. Other initiatives like Science and Technology Initiative with Indian diaspora is there. Science and technologists of Indian origins abroad. This will help in increasing the network across the world of Indians or people of Indian origin. Then an MOU, a memorandum of understanding, has been signed with UNESCO, between India and UNESCO, to have a regional center for training in biotechnology, which is a focus area under nanobiotech. So that is why I taught biotech and nanotech together, because both these things integrate. All right. In the future, there will be collaboration between these two fields. Then a national conference was done on nano technology, which is Nano India 2019. Nothing very important in this. A lot of scientific experts from all over the country came and they discussed how nanotechnology can be used for national development, especially things like drinking water, clean drinking water, material development, sensor development, drug delivery, and so on. Now come to the scheme Imprint, which is basically impacting research, innovation, and technology. So through this scheme, stress has been given to upgrading nano education and various modules. 2 projects have been initiated on nano education and 21 projects on nanotechnology and related hardware. So under this scheme, Ministry of Human Resources and Development, basically the name has changed now. So projects have been started on nano education. So basically making people aware about it. So this tells you that under this scheme, even government is aware and trying to increase the capacity or trying to build the human resource. Now this is a little bonus for you people. Now this is a rough thing that I have made, or basically rough idea to write anything. So whenever you are stuck and you have to write something, but you can't remember, the proper points. So in solutions or way forward, you can write these things that increase the funding. Mostly India has this problem in every scientific thing. So funding should be increased. You can talk about role of private sector. That means you can simply say that they should focus on research also and profit. Basically, private sector always focuses on profit, but here you can say that private sector can focus or collaborate with universities to create to have a broad research rather than only profitable research. Then students studying it improve the curriculum, update it. Basically whatever is being taught right now about technology, it should be improved like that. Then jobs in this sector, of course, that is the part of private and government collaboration, that whatever is being done, it should lead to job growth, right? So that it is helpful for the country overall. So this is a sort of framework. All right, I've talked about the keywords, framework, and perspectives, right? So this is the framework which you can use in your general answer writing. So try to maintain a notebook of general answers which you can write whenever you are stuck, right? Now, the final topic, the next big thing is really small. I hope you can see Israeli. Okay, that sounds like Israel. Israeli, okay. This is, so the next big thing is really small. So we are talking about nanotechnology. So let's talk about India and nanotech. If some question is asked about this or something like this, you can write this thing over there. So India has a lot of natural resources, and of course population is increasing, demand for water, food, shelter will increase. Of course, COVID has shown that how things get affected and how our healthcare system is working. So in all these scenario of demands from the population, we need to really have some technology that can cost effectively serve people, and that is where nanotech will come into play. So nanotechnology holds a big potential because India can really work on things while basically not depending on other countries. If we do this research, we will not be dependent on other countries. All right. So for that, what we need to do is we need to implement the projects efficiently and avoid them from the clutches of corruption. So what the government is doing for this nano mission has been extended to the phase 2, and India has a lot of skilled workforce that can be reskilled or upskilled to nanotech. All right. Then, like I said, if we create self-reliance in nanotechnology, we can make good use of the natural resources that are available in India, and then we can obviously secure ourselves also in terms of defense and anti-terrorist activities. So this is a good line. Technology is nano, but it can have a mega impact. Remember this. So if a question comes based on this thing, how nanotechnology can benefit India, you can use these lines. And of course, I'm not saying this is the perfect answer or you can't do anything else. Please go and research on your own also. Just a little bit. You don't need to do a lot. But again, we don't need to write a lot of points. So just add one or two point, whatever you think about nanotech in India. then complete the answer. Finally, in future, what do I see? Always talk about this thing, all right? Always, whenever you're thinking about new technology, always think where it will go in the future. So it will help you prepare better. So alternative energy approaches might come to help meet world's increasing energy demands. Like I've talked about storage, right? Supercapacitors. New type of energy generation might also come. Then nano satellites is a real possibility. Then multifunctional materials, something like which can be rigid also and soft also, or like something like if you have seen Batman movies, he has a programmable cape, right? So that will also based on, matlab, that is not all based on this, but some multifunctional materials can be made which can be basically let's take an example. uh, Camping, while people go camping, they have a tent, right? And it cannot be used for anything else. So let us imagine you have a bed sheet, a very big bed sheet, and when you put it on a structure, it becomes that thing only, right? Right. So the bed sheet can be used as a tent when needed, or it can be used as a normal bed sheet also. Okay. Then nanoscale additives. Additives means something which you add to something in polymer composite materials. This will create new materials like plastic, like replacing plastic. All right, replacing heavier metals and creating lighter metals. All right, so a lot of things are there which will come up, and this is a very interesting field. Whenever your exam is there, please do brush up on current affairs that are given by Amrita. All right, so that is all for this topic. We'll be finishing off nanotechnology here. All right, see you in the next lecture. Till then, take care, do revise, and thank you for your patience. Thank you for listening. See you in the next lecture. Bye bye.